Hi guys, welcome back to my channel Pirai Academy. In this video, we are going to see about a Leetcode question number 63, unique paths 2. So if you already saw the unique path 1, then you can easily come up with the solution for this unique path 2. I strongly recommend you to first go and watch my video on unique path 1 or try that problem by yourself. Then come back to this problem and try to solve by yourself. If you cannot solve that, then just watch this video. Okay, until or unless that, just don't watch this video because I want you to try at first. Okay, so you are given an m cross n integer array grid. There is a robot initially located at the top left corner, which is 0,0. The robot tries to move to the bottom right corner m-1, n-1 in this. The robot can only move either down or right at any point in time. Okay, an obstacle and space are marked as 0 or 1, sorry, 1 or 0 respectively, which means obstacles means 1, and if it is space or if it is not a blocked path, then it will be 0. Okay, in the grid, a path that the robot takes cannot include any square that is an obstacles. Okay, now return the number of possible unique paths that the robot can take to reach the bottom right corner. Okay, for example, if I take a grid like this, let me go here. If I take a grid like this, then its representation will be like this. So they will be given a matrix like that. So it is 3 cross 3, right? So it is a 3 cross 3, or they may also give like 4 cross 3 or 2 cross 2 or 2 cross 3 or 1000 cross 1000 or 1000 cross 100 whatsoever. Okay, so they have clearly said that they have given a m cross n, and see here everything is 0 here, but this thing is what? 1. This value is 1, which means it is an obstacles. Okay, now I want to start from here. Okay, and I want to go to here. Okay, so source is my top left and destination is my bottom right. Now hope you understand up to this, right? Now how I can go to the destination from the source? What are the unique paths? So see here, I can either go by this, okay, or I can go down and right, or I can either, observe this carefully, this is going to be more important. I can go either like this, then like this, then like this, but here in this square I cannot go, right? Because there is obstacles. So I can only go up to 2 parts. Now hope you understand up to this, right? Okay, so from this I can tell you the output is 2, and we want to find all possible combinations of unique parts, and we have some set of constraints, right? So from this we can tell that it is a recursion problem. Right? Because we want to try all possible combinations. Whenever there is a all possible combinations, then we want to go for a recursion. Okay, the first step for the recursion is we want to write the function, right? So function, and this function will be containing of what? Of varying parameters. What are those varying parameters that are necessary? I want this indices, right? This indices, because first is 0,0, then it may vary like 1,0 or 1,1 or 2,0, something like that, right? So it may vary. So the varying parameters are I and j. Let me take simply. Okay, I and j represent, I represent row and j represent column. Okay, now they have clearly given that we can move either to bottom or either to right. So from this I can clearly state you, hey, we are having a big problem. What is that big problem? Start from the source and end at the destination, which is going to be my base condition, and upon this journey I want to break down this particular problem into a sub problem, like either you can go to right side or you can go to down. So this is going to be my sub problem. So what are those sub problems? It will be like either you can go down, which means row plus 1, but don't change in column, or you can go to same row but plus 1 in a column, which means in a right side one step. So I want to just split my problem into a subproblem such that this subproblems will be reaching a solution. That solution may be of what? Like maybe my path is out of bound exception, right? My path is out of the range, or I can reach the destination. So these two things will be going to be your base condition. I'll be telling that clearly. As of now, just let us see the recursion tree. So if you haven't have an idea on recursion tree and recursion stack, if you don't know about that, I'll be giving the link in the description for recursion introduction video. Just go and watch it so that you can understand it clearly. Okay. So at first I'll be starting from f of 0, 0, right? Okay. So I have started from the source. Now wherever I can go, I can either go for f of 1, 0, or I can either go for 0, 1, right? Okay. Okay. Again, I can either go for f of 2, 0, or I can either go to f of 1, 1. Similarly, here also I can either go to f of 1, 1, or I can either go to f of 0, 2. Okay. So the next thing is, so currently I am here, right? Currently I am here. At for this f of 2, 0, from here I can either go to f of 3, 0, or I can either go to f of 2, 1, 2, 1. Okay. Hold on. Now I want you to understand one thing. See here it is f of 3, 0. Okay, 3, 0 means it is something like here. Whether there is some element or the index is valid, no, it is an invalid index. So whenever my row or my I is not in the range of 0 to the row index, I will be just returning what? I will be just returning infinity. Sorry, I will be returning 0 because they are asking us to find the unique parts, right? They are not asking us to find the minimum path. So that's the reason why I am returning 0. Okay, can you understand this? Because they are asking us to find unique parts. So from 0, 0, I can either go to 3, 0, but 3, 0 is not a valid path. So whenever this is not a valid path, I will be returning 0. Can you understand this? Okay. Now here also f of 2, 1. From f of 2, 1, I can go to f of 3, 1, or I can either go to f of 2, 2. Okay. Now I want you to understand another thing. So see here this f of 1, 1. F of 1, 1 means here this what? It is 1, which means hey, it is obstacles. Then you cannot go upside, right? So it will be 0. It will be returning 0. Now here also again f of 1, 1. So here also you will be returning 0 because you cannot go further. Right? So stop there. Okay. Now from this f of 0, 2. Okay. Now where can I go? I can go to f of 1, 2, or I can either go to f of 0, 3. Now again, see here f of 0, 3 means what? F of 0, 3 means it is not a valid path, right? So here I will be returning 0. Now just continue. Now here also it is what? F of 3, 1. It is also not a valid path, right? So I will be returning 0. Okay. Now again come here. From here I can either go to f of 3, 2, or I can either go to f of 2, sorry. I want you to understand something else. See here it is what? F of 2, 2. F of 2, 2 means this is the ending. This is the destination, right? So destination is the 2, 2, second row, second column, right? So this is a destination. Whenever I encounter the destination, I want to just return what? 1. That's it. Okay. Now come here. From this particular point, where I can go? I can either go to f of 2, 2, or I can either go to f of 1, 3. Now from here I can tell you f of 1, 3 is not a valid path. So here I will be returning 0. Meanwhile, it is our destination. 2, 2 is our destination. So here I will be returning 1. Can you understand this? Yes. Now come up with me. Now it will be more crucial part. Okay. So see here. First of all, here it will be returning 0. Here it will be returning 1. So which should I take? I should be taking 1. Okay. Because I will be adding both things. So 0 plus 1. Because from my left side, if I go to my one recursion call, I got 0 as my answer, which means there is nothing. In another recursion call, I got 1 as the answer. So I probably just adding them to find what are those unique values. So it will be 1. So from here I'll be returning 1. Okay, again here also 0 plus 1, it also returning 1. From here it will be 0 plus 1, so here also it will be returning 1. Similarly here it is 0 plus 1, 0 plus 1, so it will be returning 1. And here also 1 plus 0, which is equal to 1, so it will be returning 1. From here 0 plus 1, which is equal to 1. Now again from here it will be returning here 1 and here also 1. So I will be returning 1 plus 1, which is equal to 2. So 2 is going to be my output. Can you understand this? So this is going to be your entire recursion tree. Okay. Now tell me, what is the time complexity? So time complexity will be over 2 power m cross n. Okay, and space complexity will be over m cross n. Okay, so this is going to be a time and space complexity analysis, and this time complexity is because of, see here, for every recursion function, I again call 2 recursions. Okay, so for m cross n recursion, I want to call how many times? 2 power m cross n. And space complexity is because of the recursion stack and internal stack that is running, right? So now let us see the code, then we can come back and see how we are going to optimize it. So here is a Java code. If you want C++ or Python code, just search in my description. Okay, now see here, so this is the given function. Now inside that I am just writing a function call for DFS and giving at 0, 0. So these 0, 0 is a source. It's a source. Okay, always remember this, it is a source. Okay, now this grid is going to be a static, it is not going to be varying. Okay, now here this function is going to be the recursion function we are going to do. Now inside that I comma j, so I is representing the row and j is representing the column. Okay, now m is equal to grid length and n is equal to grid zeros length, which means m contains the row and n contains the maximum columns. Okay, now what are 3 base conditions I want to write here? So the first base condition is if I is greater than m and j is greater than n, then I should be returning 0. Any one of them is greater than, then I will be probably returning 0. I told that r and, right? So it is r, this r, not and. Okay, it is r. If it exceeding the boundary of my row, then I will be returning 0. If it exceeding the boundary of column, then I will be returning 0. So any one of the condition is true, then I will be returning 0. Okay, because it is an invalid path. Okay, now if the current path, the current in this element is 1, which means it is an obstacle. Whenever it is an obstacle, I want to return 0. Okay, and then whenever I found out the destination means I is equal to the m minus 1 and also j is equal to n minus 1. Last row, last column, then I will be returning 1 because it is a valid path. You have came to the destination. From here, I will be giving you a signal like, hey, you have come from the came to the correct path. You have came to the destination. So I will be returning 1. Okay. At last, what should I return? So I can either go to down, right? So for that, I'll be making a recursion call for I plus 1, but j remains same, and then I remains same and j will be incremented by 1 for right side. Now add these both things. That's it. Okay, fine. So this is going to be a recursion code. If you submit it, it will be not submitted successfully because see here n and m will be 100. So what is the time complexity? It will be 2 power 100 power 2. Which will be exceeding the limit of 10 power 9, the clock time for your program, right? So that's the reason why it will be not submitted successfully. Let me take this. Let us see how we are going to optimize it. And I want you to understand why we are going into optimization. Okay. So the second method of optimization is memoization. So from the name itself, you can understand what is my memoization. I'll be storing in my memory and I'll be using it in case of in future, in case some of the case in future. Okay, so for example see here there is only one case. Okay, but in reality there will be more than one cases. So see here it is f of 1 comma 1, here it is f of 1 comma 1, and as you know, our recursion is always a DFS approach. It's a DFS approach, which means depth first search approach, which means it will be starting from the first, then coming down, then come up, then come down, then come up, then come down, then go, then come down, like this only it will be going, right? So I can tell you I will be going to this f of 1 comma 1 first, then only I will be going to this f of 1 comma 1 next, right? If for example From this f of 1 comma 1, you may have like f of 5 comma 5, like that. Okay, then you will be going on for some other n recursion paths, right? Then only you can find the value of f of 1 comma 1 here. Similarly, here also you want to go down for n recursion calls. Then only you can find it also. Instead of that, if I store the value of this particular in my memory, then in future when I occurring the same thing, when it's occurring, then I'll be just returning the value that is stored in the memory instead of going for a recursion, right? So this is the use case of memorization. Okay. Now there are few steps to convert a recursion code into a memorization, and there are two types. One is using hash map. Okay, so it is very easy and simple. Another one is using array. Okay, so in my video I will be focusing on array, and after watching the array, okay, after watching the implementation of array for memorization technique, it's your job to just go and implement the hash map approach, because hash map approach is very simple. And also hash map has a one disadvantage. The time complexity will be slightly increasing than array. That's the one disadvantage. Second disadvantage is hash map cannot be further optimized, while array can be further optimized. Maybe, okay, not always, maybe optimized. Okay, and also I want to tell you that in real-time scenario, in real-time technical HR round, then they will be asking you to optimize till the end. At that time, at your technical HR, okay, tech HR, you want to use this technique. Okay, if it is not, if it is for your problem solving round, okay, mostly this approach will be submitted successfully. In some cases like TCS Code Vita, there only you want to go for this array approach. Until or unless that you can either submit this in a hash map. Okay, there may be a small pop-up like error message, time limit exceeded. Then you can convert the hash map into a array code. Okay, now I'll be implementing the array code. So see here, the first thing is you want to decide what is the dimension of the array, and what is the size of the array, and what is going to be the initial value of the array. Okay, so the first thing, dimension of the array. Okay, for dimension of array, I want to check for what are all those varying parameters I have. Okay, so what are all those varying parameters I have? I have only two varying parameters. One is I and another one is j. So from this I can tell you we want to construct a 2D array, a matrix. Okay, fine. Now next thing, we want to decide what is the size, right? So what is the size? So here both things are starting from 0. Okay, they will be going up to what? They will be going m-1 for I and n-1 for j. So from this I can tell you that we only want array from 0 to m-1 and 0 from n-1, which means we want an array of m cross n. We want an array of m cross n. Okay, so this is going to be the next step. Okay, so let me construct it. For example, we already saw about the 3 cross 3 matrix, right? We already saw about the 3 cross 3 matrix. For that, I'll be constructing memorization array. Let us call this as DP or anything. That's your wish. Memo or DP, that's your wish. Okay. Now here it has 3 cross 3 matrix. So that's what I told you here itself, right? Now the next step is, so what is going to be the initial value? For that, let us go back to the recursion tree. See here, whatsoever value I can get from the recursion tree, I'll be getting 0, I'll be getting 1, I'll be getting 2, I'll be getting 3. So I'll be obviously getting 0 and the positive numbers, right? So for this I can easily tell you we want to initialize some values in my DP array or matrix such that they will be having a negative value or infinity or minus infinity or going to be null. Okay, I'll be telling you why we are doing that in future. Okay, now just understand, we are going to do something like we can initialize negative value or minus infinity or null. Okay, now let me take everything as -1, but every value should be same. Okay, so everything is -1. Fine. Now what is going to be the next step? The next step is just write all these things inside. So just write all these things inside. The only difference we are going to do is we are going to modify one base condition and the return value. So what are those things? After returning these everything, at the last base condition will be like, if my DP matrix I and j value is not equal to -1, that means it is already computed and stored. So just to return DP of I and j. So this is one of the line, and the next line is before returning it, just update it. So dp of I and j is equal to dfs of I plus 1 and j plus dfs of I comma j plus 1. Okay, then return it. Then return dp of I and j. That's it. Okay, so from here I can tell you these two lines is for updating, and these two lines are for what? Are for computing, whether it is already computed or not. Whether it is already computed, I will be returning it itself instead of going for its body, the recursion body. That will be making my time, right? So this is what we will be doing to convert our recursion code into a memoization code. Now tell me, what is the time complexity? So it will be O of m cross n, and space complexity will be O of m cross n. Can you understand this? So my time complexity is way reduced. Now my space complexity is because of, one is the array we have used, this 2D array. Then another thing is because of our recursion stack. Fine. Now let us see the code for this, then we can come back. So let me comment this. So see here. So memoization technique is always easiest thing. Okay, we just going to fill everything. We want to find the dimension, then size, then fill everything. Then we are just going to add two lines so that our code is exponential, is reduced into a polynomial or linear. Okay, so see here, the first step is to initialize the array, right? So I have constructed the array of m cross n dimension and initialize every value as -1. Your wish to initialize every value as -2, -3, all negative numbers, or infinity, or int max, or int min, or you may keep them as a null. That's your wish. Okay, but in my case I'm just keeping as -1. Okay, now then I'd be just just calling the function. So these are all same. So these all are same. The only difference is here, if it is not equal to -1, then it is already computed, right? And then before returning the answer, I'll be updating in my result in a dp matrix, then I'll be returning it. That's it. So by doing this, you can convert a recursion code into a memoization code. Now I just take this, just a minute. I want to take this and let me convert this into a tabulation, the further optimization technique. Just a minute. So what is meant by tabulation? So tabulation is like, see here in memoization technique, we have a space complexity of O of m cross n, right? So it is because of the recursion stack and array. If I able to cancel this recursion stack, then I can tell you one of my space is optimized, right? So that's the reason why we are getting into a tabulation. So how we are going to eliminate the recursion? By using looping. Either it's a for loop or while loop, that's your wish. Okay, by using looping. Okay, so here are some steps to follow. The first step is we want to check whether the array or matrix that we already initialized in a memoization is correct, or we want to update anything in it. Okay, so see here, what's the dimension? It is m cross n. Okay, and everything is -1. That's fine. And we don't want to include this line also in some cases, and in some cases we want to include this line. Okay, maybe telling that clearly now. Okay, now see here, what is the base condition? So always keep your eyes in the base condition. So the base condition is, if I is greater than or equal to m, or j is greater than or equal to n, then I will be returning 0. Okay, which means whenever we are going apart from that only, we want to return 0. Okay, obviously here we are not going to be going apart, because we are going to use the looping itself. We can set the range up, go up to this only, like that. Okay, now what is second thing? Second thing is, whenever there is a obstacles, then return 0. Okay, this we will be doing in the body of the for loop, because we don't know where the 1 occurs, right? So it will be doing there itself. Okay, now the next thing is, whenever we reach the destination, we want to return 1. So there comes a twist. Because we know what is the destination. It is m minus 1 and n minus 1, right? So take for example, if it is 3 cross 3, then we will be having a matrix of 3 cross 3, 0, 1, 2, 0, 1, 2. Okay, now which one is the destination? So destination is the last index. So last row, last column. Make this as 1. Remaining everything is -1 or 0. That's your wish. Okay, now hats off, now this will be 1. Okay, now next thing, always remove this line. We don't want this line anymore. Okay, in tabulation. Now rest of them is a body of the function. body of the recursion function. Okay, now comes the looping. Now put the looping. So first we want to update or modify our matrix or array, then we can go with the looping. So let us put the first loop. So for I, so here is I, right? So this I is from where to where? From 0 up to m minus 1, m minus 1. So it is 0 from 0 to m minus 1. So in my looping, it will be from m minus 1 to 0. Just do a reverse fashion. Okay, again for j will be from where to where? N minus 1 to 0. Can you understand this? Okay. Now what is the first condition? What is the first base condition we have? It is if the grid of I comma j is equal to 1, then I should return 0. So take this first. If my grid of I and j, okay, is equal to 1, then update the particular index in my dp array as 0. So instead of returning, we will be taking that and initializing in this table. That's the reason why it is called as a tabulation. Okay. Now what is the next thing we want to do? So if I is equal to m minus 1 and j is equal to n minus 1, then what should I do? I'll be just returning 1. So I already initialized here itself. Then why do I again want to do? If I don't initialize here, then I'll be putting a condition and initializing again. So here I'll be putting a condition like if my if my I is equal to m minus 1 and also j is equal to n minus 1, then what should I do? Just don't do anything, just continue to the next iteration. Can I understand up to this, right? Okay, now what is the next step? The next step is we want to do these two things. Okay, let me split this into two things so that it will be more easy to understand. Okay, now here first step, what we are going to do? Down. So down is equal to, what is this? Solve of I plus 1 and j. So this is going to be your down, right? So for this I'll be easily writing like dp. Instead of the recursion call, always write the dp, this matrix variable, okay, of what is the varying parameter? It is I plus 1. Another varying parameter is j. Just write like this. That's it. Okay, now next thing is write is equal to dp of I and j plus 1. That's it. Okay, now at last what should I return? I should be returning the dp of I and j. So dp of I and j is stored as what? The addition of this down and right. So here write dp of I and j is equal to down plus right. Okay, now I want you to understand one small edge case. What is that? See here, if my I is equal to m minus 1 and j is equal to n minus 1, okay, then it will be continued. Okay, if my I is m minus 1 and j is n minus 2, let us take this case. Okay, now here it is what? I plus 1. I plus 1 means it is m minus plus 1 is equal to m. Whether I have this m as a index? No. At this time I want to return what? I want to return 0 because it is out of bound. Okay, so I want to add that condition here also. So before doing these lines, I want to add some more lines. So see here. Now hope you understand what is a mistake, right? So now observe this clearly. If my, let me take right first. Okay, sorry, down is equal to 0 at first. Okay, now if my current I value plus 1 is strictly lesser than m, okay, then only should I go for down. So down is equal to dp of I plus 1 and j. Similarly for right also. So right is equal to 0 if my j plus 1 is lesser than n, then only go for right. So right is equal to dp of j plus I and j plus 1. At last update in my dp. So dp of I and j is equal to down plus right. That's it. Can you understand why I am putting these two conditions? Right? Because we may go to out of bound. That's the reason why I'm just checking. So you can also use the ternary operator, like if this condition satisfied, then execute this value. Else for the down, just initialize as 0. Similarly for the right also, you can also do like that. Okay, that's your wish. Okay, in code I'll be using the ternary operator. There you can check for the ternary operator. Okay, now it is a pseudocode, right? Okay, now at last what's they written here? What is I am returning? Solve of 0, 0. So similarly here also what's they written? At last return dp of 0, 0. dp of 0, 0. Hope you understand up to this, right? So this is the entire code to change a memoization into a tabulation. Fine. So now tell me what is the time complexity. So the time complexity will be over m cross n, and space complexity is also m cross n, but the only difference is the space is because of the we have taken a matrix. So this is the reason why for the space complexity we have eliminated the recursion stack. Okay, now let us see the code for this, then we can go and continue for further optimization. Fine, so this is going to be your code for the tabulation technique. Okay, now see here. So first of all, I'm just updating my matrix, right? So there is no dimension thing. But see here, I want to check if the destination is equal to 1, then I will be returning 0 because it is going to be some edge condition. Okay, it is not going to be the logic, but it is also going to be the edge condition. Okay, so now hope you understand, like the destination may be a blocked also. If it is blocked, then that's why I will be returning 0, or else I'll be taking my destination point in my dp as 1. Can I understand this? This is what I have done in the drawing explanation also, right? Now I is from m-1 to 0 and j is from n-1 to 0. Okay, now I'm just checking whether they both are at the destination. If it's so, then continue. And then I want to check whether the grid of I and j is equal to 1. If it is so, it is the obstacles. So update in my dp array at that particular index as 0. Okay, else what do I do? For down, I'll be taking like checking whether it is in my range. If it is so, then I'll be taking the dp's down value, particular value. Else I'll be returning 0. I'll be taking as 0. Similarly for the right side also. Now at last I'll be taking the sum of them and storing in dp of I and j, and at last I'll be returning the dp of 0 and 0. So same thing I written here. Can you understand this, right? Now my next thing is I am going for a space optimization technique. So you may ask, what is in the space optimization? So see here, space optimization is nothing but we don't want some spaces. Like here we have taken the entire matrix. In real time, we want to check whether we obviously want this entire matrix, or we can do this without this matrix, like reducing some space, like one dimension. Instead of taking m cross n, I can check whether I can finish using only n or only m as a space complexity, or reducing it into a constant space also. Okay, so that's the reason why we are getting into the fourth optimization technique called space optimization. Okay, fine. Now how we are going to check whether it is a space optimization can be done or not? Okay, it is so simple. See here, always check this dp. So dp of I plus 1 and j. So here dp of I alone. Okay, similarly here also dp of I alone. So from this I can tell you we don't want entire row. We only want two rows. So those two rows will be like, one is I plus 1 and another one is I, which means I want only my next row and my current row. So that's enough. So I only want what? 2 cross column as my matrix. Can I understand this? Also just think and observe this carefully, because it is quite difficult to understand. Okay, and also if previously I have computed some values, in next iteration that is going to be my already previously computed value, right? So I can just update it, like for example, I can understand this is somewhat difficult to understand, right? So please focus on this and try to understand this. Okay, now see here, in this particular line, I only take dp as a size of column, okay, column alone, which means dp will be of size n. Okay, it is 1D array. Okay, now observe this carefully, please. It will be more difficult to understand. Okay, now here I'll be updating just like, sorry, here I'm just updating like dp of n-1 is going to be 0. Okay, and then the next change is wherever the dp is there. So here is a dp, right? So here I will be just taking dp of j is equal to 0. Okay, similarly here I will be taking dp of j is equal to, instead of taking dp of I plus 1 and j, I will be only taking dp of j alone. Okay, similarly here also instead of taking dp of I and j plus 1, I will be taking dp of j plus 1 alone. Here also, instead of taking dp of I and j, I will be taking dp of j alone. Now at last, while returning, I will be returning dp of 0. Okay, I can understand. Now you can't even realize, sorry, you can't even figure out what it means. Just a minute, just listen this. See here, I have a dp, okay, of size 3, okay. So this is for 3 cross 3 matrix. So because there are 3 columns, right? So we want only one row. Okay, now just observe this. At first time I will be updating like here there are zeros and here alone 1. So this is what I have done at this particular point, right? So here it is not 0, it is 1. Okay, at this particular point I done this only. Yes. Now in next step for this down, we want what? We want only the previous, which means the value that is stored here, it's jth position, which means the previously computed values jth position. Meanwhile in my right I only want my current positions right side, so this will be acting like both previous and also current. After that I'll be updating them both in my current, such that it will be the previous for the next iteration and current for the current iteration. Can you understand this? So my request is, please go and dry run the example with these changes. Okay, so that you can understand this clearly. Okay, I know it is impossible to just make this to understand. Okay, so that's the reason why please go and dry run this. Okay, so that you can understand why I am taking here instead of dp of I plus 1 and j, I am taking as only j like that. Okay, now the last part is, what's the time complexity? So time complexity will be m cross n. Okay, but space complexity is only of n, the column. Can you understand this? So this is how we can optimize a recursion, inefficient code into a dp, efficient code. Okay, now just come here. I will be showing the code and these changes I have done. My kind request is, please dry run this code, because by doing a dry run you can understand this clearly. Okay, now everything is similar. Here instead of doing like this, you can also return directly like this. You can just return directly like this. Okay, and then put this line. So these two lines will be equivalent for this one line. Okay, now what is the next step? Next step is go as it is. Instead of dp of I and I plus 1, just change as dp alone. That's it. So here dp of j, and here it is dp of j plus 1, and here it is dp of j. Why we are not putting I plus 1 is whether lesser than m? Okay, that's because listen this carefully. Okay, now here it is dp of I plus 1, but instead of that we have taken as dp of j alone. Instead of taking dp of I plus 1 and j, I have taken only dp of j. So that's the reason why we don't even care for this I plus 1. So that's the reason why I just try code this. And I will directly initializing them down as dp of j. That's it. Can you understand this? That's the reason why I have initialized here also. At last I will be storing them in the dp of j. and then at last I'll be returning the dp of 0. That's it. Okay, now I want you to just go and dry run this. Okay, or you may also use like a 2 cross column matrix for initially. Once you got enough practice on this, then you can go for the 1D array as it is. Okay, like I used here. Okay, so that's it. So it is hard to understand, but DP takes time. So just go and dry run each and every approaches so that you can understand this clearly. Okay, it takes around 1 hour or 2 hours, because I personally took 3 hours to understand one problem, all the methods. Okay, it also takes you for 1 hour or 2 hours. That's the mindset. Okay, so that's it for this entire video. If you really understand this, please like this video and subscribe to my channel. If you want to know about these kinds of algorithms, just go and search in my YouTube channel. And if you have any doubts, okay, just comment below. I'll be commenting the answers. Okay, thank you.